Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. We've got an important topic for you today. Here it is. Using the new IO-Link Masters with Horner OCS. Now, we think this is an important topic because we've just released 2 new IO-Link Masters, and you need technical information if you're going to apply those with the Horner OCS. So the goal of today's session is to provide as much of that technical information as concisely as possible for you today. Now, because I am traveling this week, I will be solo, so no product manager Casey Gardner today. But remember, next week, if you're watching this live, we're going to be in Detroit, Michigan at the Automate Show, and you'll have an opportunity to meet me and potentially Casey if you attend the show. So we'd love to see you there. All right, let's dive into the IO-Link Master information, and let's see how we're going to break down today's topic. Okay, we're going to start by taking a quick look or a quick review of IO-Link. So we're not going to belabor it, but we're going to spend a slide or two getting you caught up on what is IO-Link and what are its advantages. We're going to reintroduce to you very quickly the Horner IO-Link Masters. We're going to tell you what components you're going to need if you'd like to apply IO-Link with the Horner OCS. We're going to go through all the information you need to know to configure the IO-Link Master and IO-Link devices. And we're going to show you the steps required for Cscape configuration and programming. And throughout, we'll have plenty of demonstrations. Let's get started. Here's our quick review of IO-Link. First of all, let's talk about what IO-Link is not. It's not a field bus. It often gets confused with field buses because people think of using sensors and actuators over a network. They think field bus. Well, IO-Link doesn't feature multi-drop connections or Ethernet connections like a lot of field buses and industrial Ethernet networks do, but instead it utilizes point-to-point communications. The whole point of IO-Link is to improve and modernize the integration of sensors and actuators with automation systems, specifically with PLCs and devices like the Horner OCS. Now, IO-Link does offer several advantages, and we'll just list 3 of them here. So one advantage of IO-Link devices is that they typically provide extensive field configuration. What does that mean? Well, it means they can be customized in the field using configuration, so you've got a much better chance of ordering an off-the-shelf sensor or actuator and then configuring it in the field to meet your exact requirements, and not having to buy a build-to-order sensor or actuator, reducing your acquisition time of the components, which is very important these days, as we all know. Another advantage of IO-Link is that the device data, because it is digitally communicated, is not limited to a single analog or digital signal, but it provides access to more data and more exact data. A third advantage of IO-Link is that the IO-Link Masters, those are the devices between the OCS or PLC and the IO-Link devices themselves, the IO-Link Masters have the capability of storing device configuration. So, if you ever have to swap out a sensor or an actuator in the future, and it has some non-default configuration settings, the Master is capable of reloading a new unit from the factory with the exact configuration required for the application. That can minimize your downtime. Another big advantage of IO-Link. Let's talk about the 2 Horner IO-Link Masters that are now available. We've got a 2-channel model, as you'll see in the upper right-hand corner, and a 4-channel model at the lower center. Now, we did not manufacture these products. They're designed and manufactured by Banner Engineering. They work extremely well, and they integrate with the OCS extremely well. Now, they actually interface over either the MJ2 or the MJ3 port on the OCS, and they communicate using Modbus RTU. But don't worry, the communications is actually quite snappy. So I've been pretty impressed with the update times with the IO-Link Masters to OCS. So what are you going to need at runtime in order to use IO-Link and design it into your system? Well, you're going to need pretty much any modern Horner OCS. So what does that mean? Well, It could be a micro OCS, it could be XL series OCS, it could be XL Prime series OCS. When the Canvas series is released later this year, those will also be compatible. So really, any modern OCS. You'll need one of the two IO-Link master models, either the 2-channel or the 4-channel, and you'll need a cable to connect the two. Now, we've got a cable that we've designed that will be available that you can order. The part number is there on the screen. That will effectively link the IO-Link master with the OCS through the MJ port. And it not only provides Modbus communications between the two devices, but it also provides a way to get 24-volt DC power into the IO-Link master to power not only the master, but also the IO-Link devices themselves that are connected to the master, up to 4 amps at 24 volts DC. And then because most IO-Link devices are based upon M12 type connections, you'll need some M12 cord sets more than likely. Now, there is configuration required. As we talked about, that's actually one of the benefits of IO-Link is the fact that you can configure sensors to your needs, and you can store that configuration in the IO-Link master. But to make that happen, you're going to need some software, which is free, developed by Banner, available either from the Horner OCS website or the Horner Automation website. You can even download it from the Banner Engineering website as well. And then there's another piece of hardware you'll need for configuration purposes, and that is an IO-Link configuration adapter, which effectively allows your computer via USB to connect to the IO-Link master, provide power to it during the configuration process, and configure not only the master, but also the IO-Link sensors and actuators that are connected to the master. Let's take our first look at the IO-Link configuration cable. Okay, so this is the IO-Link configuration kit. Let's take a look at that. Now, at first glance, it looks like a bit of a mess, but it's actually a clever design. It starts with this yellow housing where all the electronics are housed, because there are some electronics involved here. You can think of it like a Y cable. So at the bottom of the Y, you have this M12 connector, which is where you would plug in your IO-Link master, either the 2-port or the 4-port. Okay, so that will plug in here. Now, the system is going to need power during configuration, so a 24-volt wall wart is provided as well with, looks like about a 2-meter cable that's currently wound up. If your AC mains input looks a little different than this, your plug style looks different than this, then don't worry, there are adapters included as well. And then at the third leg of the Y, we have the USB cable here, or the USB connector for plugging into your USB-A port on your PC or laptop. Now, not all IO-Link devices are M12 based. A lot of them are, but they aren't all. So also included in the kit is this adapter, which can convert from M12 to open wires. So you can connect that either to a IO-Link device that has open wires itself, or maybe it has an open terminal strip. So that's also included in the kit. All right, so that is the IO-Link configuration kit for the IO-Link masters. Okay, now that we've seen the configuration cable, let's move on to the next step in the process, and that is IO-Link device and master configuration. Okay, let's go ahead and configure our IO-Link devices that are connected to our IO-Link master. So here is the IO-Link master, and this port is connected to my computer through the IO-Link configuration cable. So it's that Y cable we just reviewed. So this is the M12 end of that cable. And then, of course, the USB end is connected to my laptop. On port 1, I'm going to be using this sensor, and on port 4, this light tower. So I've got them configured where they're going to be used at runtime. All right, let's go to the computer now, and let's fire up the IO-Link software. All right, I'll go ahead and maximize the screen here and hit connect. Now it pops up with all the different USB to serial devices that it found, or the COM ports that it found on my computer. The only one I have connected is the IO-Link config kit, so that's COM5. I'll hit the connect button here. and now it starts loading information from the ports. Now, up here in the upper left-hand corner, it shows that it's found something on port 1 and port 4, and then it's also given us a message saying that we don't yet have the IODD file, which is the IO-Link data file for the Q4X, which is the sensor. So I'll say OK there. Now it's continuing to gather data, and it's now telling me it doesn't have the IODD file for the light tower either. All right, so it's done gathering information. It's found the device here and the device here on port 1 and port 4 of our 4-port master. Let's go ahead and load a couple of IODD files for these devices. So I'll hit the Load IODD button here. And what I have done is I have previously downloaded the zipped up files from the manufacturer's website, which basically is Banner Engineering in this case for both the sensor and the light tower. And now I'm going to go ahead and start with the Q4X. Now there's 2 files here. I've got 2 shots at it. I think it's this one. Let's open it and see. It'll tell us if it doesn't match. Okay, that looks good. All right, now let's go ahead and load the one for the light tower. Need to go to the same location again because that's where I put the files. You can put them anywhere you want. I just decided to kind of file those with the software in the softwares folder there. Okay, so those have been loaded. All right, so now let's start with the sensor. Okay, so I'm switching to the tab for the sensor. And I could actually read the parameters. Let's do that now. So these are all the configuration parameters for the sensor. And I can read those parameters, and then I can go through and change them as I choose. Okay, now there's a lot of sensors available, or I'm sorry, a lot of parameters available on this sensor. It's got them all sorted here. And user variables is another section here. So I could go in and change these as I please. And then as I made changes, I could write those parameters to the sensor. So that's what I would typically be doing. Now in my case here, I'm going to use the sensor in its default configuration. All right, now let's head to the light tower. All right, go to its parameters and hit read. And it's going to read the parameters for the light tower. Okay, now I happen to know that, at least in my setup, that one of the default parameters for the light tower needs to be changed in order for things to work the way I want them in my application. And specifically, with all these parameters available, the mode selection is the parameter that I need to make sure is in run mode. And I previously changed it to run mode, so that's why it says run mode here. But from the factory, that light tower comes, I believe, in level mode, which will not work with my application, at least the way I want to use it. So therefore, I had to change that parameter to run mode. But I did it before I started recording, so that's why it's already set to run mode. Okay, so the idea is that you connect to your devices that are going to be through the master, that are going to be the ones you use in the application. And then when you're done with that, one of the things you may want to do, because it's one of the advantages of IO-Link, is to actually set up the IO-Link master so that it will automatically restore the desired parameters to any new factory device that's plugged in later, maybe when you have to do a swap out of a sensor or a light tower or something like that. So we're going to go to the tab on the R90C, which is the 4-port master here, and then we're going to select port setup. So you can see here, here's kind of our default settings for each of the 4 ports. And you can see the vendor ID and device ID for each of the devices that we have connected to port 1 and to port 4. Here's the sensor, here's the light tower. Okay, so what I want to do then is let's go ahead and set this up so that I can actually, again, restore a new factory installed sensor, for instance, to the parameters that I want to use at runtime. Okay, so what's the process like to do that? Well, we start by switching the port mode to IO-Link manual. So on port 1, we're going to change this to IO-Link manual, and then we're going to select backup and restore. So this is our initial starting point for setting up this port the way we want. So I'm going to write this mode. Okay, so that's now been written. Okay, so now what I need to do is I need to unplug the sensor and plug it back in. So I'm getting it in my hand right now, and I'm unplugging the sensor. I just now unplugged it. Okay, and then I need to plug it back in. All right, and then the lights are flashing on the device, and it appears to be done with the sensor. So that's done. Now I need to switch to restore and write that parameter. And notice what happens to my connected light over there in the corner. Let's write that. Okay, so that has now been written. So at this stage, we should be able, or this port should be in the mode where it will automatically restore any factory sensor that's plugged into that port that has the same vendor ID and device ID. The IO-Link master itself should restore that configuration to that sensor. All right, let's do the same thing for the light tower now. Okay, so let's go through that process again. Let's press IO-Link manual here. And let's go to backup and restore. Let's write that. So that's been written. Now we need to unplug and replug in the light tower. So I'm doing that now. I'm unscrewing it, unplugging it. Okay, now I'm plugging it back in. Told me the device was no longer connected. Okay, so I got a message there. Okay. So that's now been plugged back in. Now I need to switch to restore mode and write that. Okay, so now, again, my light tower has been set up so that if a fresh light tower comes from the box, it'll be able to have its configuration set the way I want it, because that's stored in the IO-Link master, and we'll be able to get back up and running much quicker than if we had to do everything manually. Configuration of the devices and the master is now complete. Let's move on to Cscape. Okay, let's take a look at Cscape. And let's do what we need to here in order to communicate with our IO-Link masters. All right, now it's mostly configuration that we need to do. Remember, in our case, we have a sensor right there and a tower light right there. We've got a 4-port master here, and we've got our Horner cable, our Horner Y cable, that connects MJ2 of the OCS to the master and also provides power to the master. Okay, so back to Cscape. Let's take a look at the hardware configuration where a bulk of the work is done. Now, today I'm showing you variable-based advanced ladder. We also do have a register-based example that is posted along with the variable-based example. So you'll have both available to you, so you don't have to use variable-based advanced ladder. So from a configuration standpoint, I just opened up hardware configuration and I'm going to serial ports, because remember, MJ2 is a RS-485 port. Okay, and there we go. MJ2 we have configured for Modbus Master. So we have a variety of choices on this pull down. We've selected Modbus Master. Okay, let's take a look at the network tab, or the network button here, and take a look at our settings. We want 19200, no parity, 8 data bits, and 1 stop bit, Modbus RTU protocol. Okay, those are the critical ones, and that will match the default settings on the IO-Link master as it's shipped from the factory. Now I've changed a few other parameters here as well. I've set the number of retries equal to 2. That's a reasonable number. That means that the OCS will attempt to communicate with the master 3 times consecutively. It'll wait up to half a second for the master to respond. Normally it's going to be responding much, much quicker than this, but these are the changes that I've made to the defaults. Under the scan configuration, I've set the update interval at 0. That means it's going to scan as fast as it can. The MJ2 port will be scanning the IO-Link master as fast as it can. And I've set reacquire time to 1 second. So basically what that means is if we have 3 consecutive failures where we don't get response, we'll wait a second and then we'll try 3 more times. So again, most of the time, the IO-Link Master and MJ2 are sitting there cranking along, no problem. So these are some good settings here. A couple other things. If this is a dedicated network, or a dedicated network, in other words, there's nothing but the IO-Link Master and the OCS talking to each other, and that's all, there's probably no reason to enable, or to utilize, I should say, the disable bit, which is optional, because there's no reason to disable it because you're always going to be wanting to talk to it. And I will also say that it's always a good idea to take advantage of status with the communication. So what we have here is an array of 4 32-bit values that is going to tell us the poll response time in milliseconds, the number of no responses, bad responses, and good responses. So that's always good information to have, especially if things aren't working the way you expect. So that is the configuration on the network button. Okay, now we go to the device configuration. And if it is a typical application where the only device that the MJ2 is communicating with is the IO-Link Master, then there's just one device we need to add. So I've previously hit add, and we gave the device a convenient name, in this case, IOL_master. The ID is pretty much irrelevant. Actually, that's not true. The ID is relevant, and the default at the factory is 1. So I've set that to 1. The defaults of Modicon 5-digit addressing, and the device supports all the function codes, is perfectly fine. Again, no reason to disable the device to take advantage of that optional feature, and then enabling status for the device you're talking to, in this case, our IO-Link Master, is a good idea. And that, I believe, tells us, if it's all zeros, I believe that's all indicative of a good status. Okay, so that's everything we need to do on the device level. So we've configured the network level and the device level. Now we need to create a scan list. And the good news is the scan list is very simple. Based on the port that you are communicating with, remember the IO-Link Master will either have 2 ports or 4 ports. The variables, or the registers, that the Modbus registers that you need to poll either reading or writing to, are pretty much fixed. So for the first slot, in this case, we've got the Q4X sensor connected to the first port on the master. The read data is hard mapped at 41001. For port 2, it's 42001. For port 3, it's 43001, and for port 4, it's 44001. That's the read data, not the write data, but the read data. And there are 17 words worth of information. We are reading that information and copying it to a local integer array called Q4X in data that has 17 different elements to it. And we always put the first element in the list if that's the one we're starting the writing with, and we are. This is a polled read. Okay, and then our only other device is our tower light. And with the tower light, it only has output data. And remember, output data is 50 offset from the input data. So for slot 4, any slot 4 input data would be 44,001 or 44001. The output data for that same slot is offset by 50 from that, so 44051. And that's what we've configured here because this tower light only has output data. Again, with a length of 17 words. We've got the local source here, which is an integer array of 17 elements. And this is a polled read write. So that's all the configuration that's required on MJ2. Okay, and everything else is really just a matter of taking the data from the sensor and interpreting it based on the documentation for that sensor. Or in the case of an output device like our tower light, taking the data sheet for the tower light and setting the outputs as appropriate to make the actuator do what you want it to do. Now, in this particular case, we have just a little bit of sample logic in here. Under Q4X, I've got a routine here, a little logic routine here. Basically, the Q4X is a distance sensor, and it's providing its data in the 4th through the 16th bit of the first word of data coming back. I'm sorry, the second word of data coming back from the sensor. So we are shifting down 3 places to get rid of the 3 bits that we don't want to look at. And the result is our measurement value. With the TL50, the only thing we have to do really, besides interpreting a bunch of data or taking data and writing to that device based on the data sheet, is we have to set the first bit of the first output word or first output byte to a 1 so that we can write to it. But that's specific for that particular device. Let's take a look at our bench here. Okay, and as you can see, we have our Q4X sensors giving us a reading of 1170 or 1171. It's down here firing to a target. Okay, you can just see the little red dot there, that it's a reflection of its target. And then on the tower light, we can control it through these text table objects here. So if we want to change the color to a different color, for instance, change it to red, we can do that here. We can change the animation, we can change the intensity, all those things. And again, all we're really doing is changing data in the OCS, and then that data is effectively being written to the tower light. And again, depending on the IO-Link device you have, you're going to be writing different data to different IO-Link registers. Okay, so that's pretty much all the Cscape work that has to be done for interfacing with our IO-Link equipment. Okay, that's it for the demonstrations. It's time for a wrap-up. The IO-Link masters and the IO-Link devices are configured using free configuration software, and you will need a USB-based IO-Link configuration adapter. Both of those things are available from Horner, the software on the Horner website, and the configuration adapter available as a part number. Now, from a programming standpoint within Cscape for IO-Link, there's really 2 things involved. The first is setting up the communications with the IO-Link master, and the second is really reading and writing data to the specific IO-Link devices that you're using in your application. And the specifics of what data needs to be written where is pretty much dependent on the specific IO-Link device you're using, and you can find that information in the user documentation. Over the summer especially, and as time goes on, we will continue to develop additional programming tools through the use of user-defined function blocks and other tools, which will make the entire process easier, so stay tuned. This is the point in the program where I remind you that we're here every Tuesday, whether we're fully live, partially live, or pre-recorded like this week. But in any case, we always have people standing by live as we stream the video to answer any questions you might have. And if you're watching this on replay, like a lot of you do, we'd love to see your questions and your comments in the comment section on YouTube. This year, we're celebrating 10 years of Horner lighting products. Don't miss the great Horner lighting videos that you'll find alongside the Horner automation content on our YouTube channel. Next week, we're going to be live from Automate, or at least recording live from Automate. Of course, we've got to worry about bandwidth, especially cellular and Wi-Fi bandwidth at a trade show, which is always a little bit dicey. But I guarantee you, we will be recording live and present that to you Tuesday at 2 o'clock. Now, the details of the show are this. We are at booth 2044. The name of the show is Automate 2023 in Detroit, Michigan at the Convention Center downtown. And it's there from May 22nd through the 25th. I'm going to be there the entire time. Part of the time, you will be able to meet Phil Horner, our owner, or Casey Gardner, our product manager. So don't miss it. Booth 2044 at Automate 2033. Oh, wait, 2023. Let's not get ahead of ourselves here. Okay, so if you haven't done so already, please subscribe to our channel. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until I see you again, let's all get out there and do us some good.